In this video, I will introduce the Ethereum blockchain smart contract lottery system as designed by me, Lawrence Wu. The smart contract lottery system utilizes multiple complex components, but the core logic is pretty simple to grasp. We'll begin by explaining the primary component, the smart contract, and how it works. Next, we will deploy it to the blockchain and interact with it. Finally, we will show the proposed physical vending machine deployment of this lottery system to retain familiarity for conventional paper lottery users. First off, the blockchain is a decentralized, irrevocable shared ledger of transactions that have the properties to facilitate financial transactions, with its most famous application in the cryptocurrency Bitcoin. In Ethereum, the blockchain can be used to store code that regulates these transactions, known as smart contracts. Ethereum smart contracts can emulate any financial instrument and enforce financial transfer without the need for an active centralized authority. Smart contracts in Ethereum are composed of relatively short code in its own Solidity language. To develop and show the functionality of these smart contracts before final deployment on the blockchain, the Solidity browser-based compiler is used here. This lottery smart contract is a simple construct that takes bets with cryptocurrency from users through their Ethereum wallets, publicly shows the list of bets and users involved, and allows the initial sender of the contract to be the owner, who is then able to close the contract to pay out lottery rewards. The functionality of this lottery smart contract can then be shown from this compiler. We first deploy the contract to a virtual blockchain, which has multiple accounts loaded with cryptocurrency for us to use. After creating the contract, subject to a transaction fee called gas, the user is able to run the publicly exposed functions of the contract. We can now see that the account we use has spent a small amount of Ethereum cryptocurrency as gas to make the smart contract run. This also makes it the contract owner, the only account on the entire blockchain able to end the lottery to start a payout, perhaps at a preset deadline. To begin betting, we will switch to another wallet and bet 5 Ethereum into the contract from there. This bet has been stored in the blockchain. The bets and other information relevant to the contract are stored in the variables and mappings in the blockchain as shown in this segment of the code. To allow users such as accountants or auditors to get information about who made bets on the smart contract, accessor functions are made available to everyone to easily make inquiries. We have thus made 2 users bet a good amount of cryptocurrency into the contract. The owner then reaches the lottery deadline and then ends the lottery, deciding a winner and paying out to them. To deploy the contract, we have put together our own self-hosted Ethereum blockchain testnet with preloaded wallets. The blockchain can thus be seen from the logs as depicted here. We then deploy the lottery contract to that blockchain with the truffle compiler, and the contract is now available at that address listed here. Now that we have all the infrastructure in place, we now introduce our web-facing UI, which allows both remote users familiar with cryptocurrencies and local users. Now that we have all the infrastructure in place, we now introduce our user-facing web UI, which allows both remote users familiar with cryptocurrencies and local users who may prefer cash and paper. Now that we have all the infrastructure in place, we now introduce our user web-facing web UI, which allows remote users familiar with cryptocurrency to interact with the contract anywhere with an internet connection. For local users who may prefer cash and paper, we provide a vending machine on site that shows the same UI, but is also equipped to dispense cash and paper wallets. First, we will have a paper wallet dispenser that provides wallets available to purchase. It can also dispense their preferred amount of cryptocurrency to a given address. This way, the user at the vending machine will only need to hold this paper wallet to participate or receive any earnings in cryptocurrency. They also don't have to go through the trouble of buying cryptocurrency, for we will provide that exchange service for them. And finally, the user is responsible for keeping the private key safe, just like they would a lottery ticket or cash. To interact with the smart contract web UI, we equip the browser with a special add-on known as MetaMask. This allows the browser to connect to the Ethereum network and control its wallets from its private key. To interact with the smart contract web UI, we equip the browser with a special add-on known as MetaMask. This allows the browser to connect to the Ethereum network and control a wallet from its private key. The user scans their wallet into MetaMask to allow it to make bets in the smart contract. We then choose a number and make a bet using that wallet. Now that all the bets are placed, we use the owner account to end the lottery. Now we see that our account 6, which bet 2 units of cryptocurrency, has lost the bet. The collective amount was instead distributed to account 7, which picked the winning number. This amount of cryptocurrency can be redeemed right from a machine in cash if it is a small prize, like under 1,000, or guaranteed in large amounts at our office for large prizes, or physical prizes, or in cash. Or, if the winner is not physically able to reach us, they can exchange this cryptocurrency at any exchange on their own. Many of the improvements that the blockchain brings come in the back end of the lottery system, but ideally, the experience for the user is mostly the same. They make a bet, get a paper voucher, keep it safe, but if they are a winner, they get the winnings immediately wherever they are, exchangeable to cash in person from us, or bank transfer remotely through any exchange such as Coinbase. There are 4 main benefits that this blockchain system provides to lottery organizers and other stakeholders such as auditors. First, there's accountability. This saves the regular effort since they can see the lottery occur on the blockchain right away without any risk of accounting tricks or bureaucratic delays or the inevitabilities of time dilation. From the code, we can also see that the owner cannot simply rig the game. The mechanism is clear to all. Next is user end simplicity. Users of paper tickets ideally see little difference in obtaining, handling, and redeeming tickets. The only difference shown here is that the ticket may be a bit easier to scan. So there's greater user participation rate since users anywhere on the internet can participate in the lottery without having to come in person to get a ticket or get the winnings in cryptocurrency. Finally, there are customization options. If the game can be expressed in mathematics, it can be made. A simple raffle drawing or more advanced betting system, maybe attached to external information oracles, can be used. However, there remain certain risks that the lottery must be aware of. For one, the organizer does not have to operate their own blockchain when they use the strength of the Ethereum blockchain. However, this means it becomes subject to its price variability and traffic conditions, much like weather and vehicular traffic would affect physical events. Another issue is that security is paramount with smart contracts, because a minor bug could result in tremendous financial loss, and issuing a new contract can be difficult. This is why each line of the code and any new configuration must be well tested. But there are methods to provide test-driven development. Even so, the promise of a digital financial instrument that enforces the contract itself and remains immutable without the guarantee of force from a central authority is a revolutionary step in accounting and the digital economy as a whole.